my name is Teemu Salo from Tampere University, and I'm here to introduce you an idea so we can actually use carbon non-woven clothing to make RFID antennas. But first, mandatory selling about Tampere University. So it's nice to see all you here. And yeah, we are the second largest university in Finland, so no worries, students are at the moment in their summer holidays, so that's why they're so peacefully. And hopefully you can have some spare time to visit lab of Future Electronics, which is focused on printed and flexible electronics in Hervanta campus. But to the main topic, so 2 words, wearables and RFID antennas. So about wearables, so typically, as you know, you have electronics all over you. So basically you can have mobile phones on your pocket, so you can think that basically it's also wearable, as it now is in a pocket. And also you can have ring watches and other stuff. These are quite nice electronic devices because these are hard. So that it's very easy to just put very small, efficient components in them. But if you want to have electronics in a larger area or on different body parts, so then you need to put electronics on clothing. And also, if you put electronics on clothing, then you can also improve the functions of clothing, for example, warming or lighting. And of course, then you can also track the locations of clothing or user which you refer. And to make actual electronics nicer and more usable, so then it's nice to use stretchable electronics here. And well, what is the stretchable electronics? There are 3 elements. So first, there are very deformable substrates, which can be from thermoplastic polyurethane, silicone, or textile. And on top of it, you add stretchable interconnections, which can be made with different ways. It can be screen printed, it can be made from copper foil meanders. And between these very stretchable interconnections, you add small hard PCBs. These are islands which do not affect the total deformation of the system. So the composition is in the end still stretchable. And after this main phases, then you can just laminate the whole system on a jacket or other textile, so that is when it's a wearable stretchable electronics. And as you heard, there are so many different ways, different manufacturing methods included. And the second word was the RFID antennas. So I think here we have quite many experts here in this field, but yeah, so these are quite nice devices. So battery-free, very simple one, antennas. So you can, yeah, with this you can track the clothing, or then you can also sense some changes in the clothing made by user. For example, tags can absorb some moisture and other stuff. And yeah, so in these tags we have antenna and the IC. So very simple devices, thus they are cheap and durable. And these can be made with many different ways. So for example, with our neighbor research group had done this by punch needling. So there's many ways to do these antennas. So if you like textiles and handwork, you can also make these kind of antennas by yourself. But to the main topic, conductive carbon fiber clothing. So here we applied this very actually quite common material in these antennas. And why we wanted to have these carbon fiber cloth in this? Well, it's very thin, light, and permeable because it's it's 150 micron thick only, and it has up about 2.5 millimeter length staple fibers. That's quite uncommon length of the fibers here, which is not used so much. And it's very cheap, standard industrial product. And it has, well, we are talking about carbon, so it has quite good conductivity for that. Well, it's highly flexible. And if we integrate this carbon fiber inside a stretchable matrix, for example, from TPU, then this composite is stretchable. So then we can again have stretchable electronics, for example. But of course, there are some bad things. So, well, it's carbon, so it's not as conductive as metal or copper. And then it's weak material at itself. So it's a composite material, so it needs some substrate with it. And how we did these stacks. Here are the size of the stack and very simple drawing how it's made. So first we had a raw carbon fiber cloth, which we laser cut to correct shape. Then we laminated TPU on the bottom and then just placed antenna on the other side and then laminated the second layer. Very simple, engineer would love it. And then we had also the fourth one, so we wanted to have more carbon fiber there, so then we also tried to add additional layer of TPU there in the middle. So here you can see the 4 different antenna types which we did. And how we tested these antennas. So we had 5 parallel samples, and then we measured the resistance of these carbon fiber antennas. You can see there the resistance measurement points, and then we use this quite portable Thingmatic Mercury RFID reader. And then we place antenna either on the foam threshold or on skin. And of course, this is first test. So in future, we also like to do simulation and other stuff. And the results were quite promising, I have to say. So we noticed that actually, if we added conductive adhesive between the IC and the antenna, that didn't make a big change actually. So then actually we can maybe forget the conductive adhesive from there. And also quite logic thing. So if we add more carbon fiber, well, it's more conductive, so that the resistance decreases about 40%. And then one nice finding was that if we add more TPU in the antenna, then also it's better encapsulated, so that also the effect of the skin to the reading range was decreased a little bit. And but of course, as we also this was also the manufacturing was part of the test. So we also noticed that if we add this thickness of the carbon fiber layer a little bit more and more, that also can break actually the IC. So that's also one challenge in the future. So we want to make as thin conductive layer as possible. And well, 1 meter reading range was okay at this stage, but then we also aim more. And what we then did after this, so we wanted to make some nice results. So then we added some glitter pads. So it's possible, for example, to hide these antennas on your jacket, and then you can follow your children where they go, for example. But yeah, there are some next steps. We want to increase amount of TPU in the other side of the antenna, so that it works better when it's on your skin. And also we want to increase conductivity of carbon fiber layer, and we have one idea, so we can metallize the carbon fiber cloth. And of course, now the shape of the antenna isn't so much optimized. So now it's just a standard shape which we have used a lot. And yeah, so a new interesting test would be, for example, well simulations, and then of course this washing test, so that actually when this IC and antenna is between two layers of TPU film, so in theory it's also watertight. And of course new applications. Let's see where we can use these antennas, how we can use these as sensors in the future. Thank you.